Hey YouTube, it's Dimitri. Today we're going to do arithmetic operators for vectors. Okay, so we can do simple things. So vectors can be added, subtracted, multiplied, and divided. So remember in R, there are no scalars, but we're going to pretend there are because using scalars is kind of useful. Again, these are not scalars. These are just one element vectors. But let's just create a list here and I'll show you how it works. So x is going to be equal to 1, 2, 3, 4, 5, 6. And if we run this, okay, so I'm going to let you guys know here on the shortcut for running when you have code in here. I'm going to copy and paste these in so you can see me actually doing it. But if you wanted to run like this line of code, you could either highlight it or you can just put your cursor on it and then click the Alt button on the keyboard and hit enter, and it will run all of your code here, or at least the chunk of code that you have. So this is one chunk because there's no spaces between it. But anyways, I'm going to copy and paste. And you can see here we have x, which is 1, 2, 3, 4, 5, 6. You can type in x and print it. But let's do some arithmetic here. So let's do addition, and let's just do x plus 4. And you can see now that 4, almost like a scalar, is added to every single element in this vector. So 4 plus 1 is going to be 5. 4 plus 2 is going to be 6, and so on and so forth. Simply here, subtraction does the same thing. So let's do x minus 2. And we'll copy and paste this. And you can see here that you have, again, our list. So 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1, and so on. And then let's simply do multiplication quickly here. So let's just do x times, 3. And we'll run this. So we get exactly what we expect here. We have 1 times 3 is going to be 3. We have 2 times 3 is 6. 3 times 3 is 9. And you can keep doing the math. And then finally here, let's just do some division. Let's just do x divided by 2 for simplicity. And again, we have 1 divided by 2 is 0.5. 1 divided by 1 is 1. You'll notice, though, that the vector has to take all of the same type of data inside of it. So because 2 divided by 2 is going to be 1, which should be an integer, the other pieces, for example, like 1 divided by 2 is half, has to be a decimal point. And so since you have a decimal in here, everything has to have the exact same. If something were to have 2 or 3 decimal places, everything in here would have 2 or 3 decimal places. Okay, and you can also do operations between vectors. So what do I mean by this? I mean, if you had a vector y and it was going to be equal to, 10, 11, 12, 13, 14, 15. Okay, so we'll take these and run these below. You can see up here we created y, and then again we took x plus y. So x was 1, 2, 3, 4, 5, 6. 1 plus 10 is 11. 11 plus 2 is going to be 13, and so on and so forth. Okay, so before we move on here, I'm going to give you an example of a model using different operators. In R, you can use functions to create models, but let's say we had some model such that, so in linear algebra, you have y is going to be equal to alpha plus beta of x plus, we'll say beta 2. So this is beta 1. This is beta 2 of x. We'll say of, z. So it'd be like y is equal to your intercept and then plus your 2 slopes. And let's pretend here that beta 1 is going to be equal to, 0.5. And we're going to say beta 2 is going to be equal to, 0.3. And we've already created x above, so let's just create z real quick. So z is going to be equal to the same size of the list. Let's say 5, 10, 15, 20, 25, and 30. And then if we are going to predict out y here, so you're going to do this, your beta 1 and your beta 2 are essentially like scalars. And I forgot to add here alpha is going to be equal to, say, 2.5. And you could actually run this calculation and create your new vector of y here. Okay, and now we need to assign the beta 1, beta 2, and alpha real quick as essentially like scalars, but let's say the alpha coefficient or your intercept here is going to be 2.5, and then we'll say our beta 1 is going to be 0.5 as we stated, and then beta 2 is going to be 0.3, and you can run all these, so we need to run z with it. Okay, so now we have created a b1, x, b2, and z. And then we're basically just going to do, right, multiplication in these two scenarios, and then we're going to add them all up. So let's just do this as one equation. Let's say y is going to be equal to alpha, which is a, plus b1 times x plus b2 times z. So this is the same equation from here, but you can see here when we run this, this is like these ones here. So alpha, beta 1, and beta 2 are one element vectors that are going to be either added or multiplied all together. And you can actually run this and we can see what we get. Let's print out y. Okay, let's just do a little bit of math here so you can see how it worked. Okay, so we have 2.5 plus beta 1 x1, and beta 1 is going to be 0.5, 0.5 times 1, so the first element in x is going to be 0.5. So let's just do this example underneath. So we have 2.5 plus, this is going to be 1 time, or this is going to be 0.5 times 1 plus beta 2, which is 0.3 times 5. This should give us 1.5. So 1.5 plus 0.5 will give us 2, and then 2 plus 2.5 will give us 4.5. So this is what we expected, and this is what we actually got for the first portion of y. And then again, it would go through the entire list of x and z, keeping your intercept, your beta 1, and your beta 2 constant. But this is just a real-world example of like a linear OLS model. Again, you can use functions to estimate this, but if you wanted to hand score something for, I don't know, some reason, this would be an actual use of using operators and vectors. Okay, so now to move on here, so doing operations with a vector on a vector is also possible. Let's remember, this is not linear algebra. So we're not going to do like matrix multiplication or anything like that. But what we're going to do quickly here is we're going to do x times z. So x and z are the same length. And we're going to say, okay, x times z. And if we run this below, you'll see that it went across. So it's going to be x and z here. So let's print them out real quick. So you have 1 times 5 is going to be 5, 2 times 10 is going to be 20, 3 times 15 is 45. So you see it just goes across the lists element by element. So it just matches them up. But also here, remember recycling. So if you didn't watch the last video, recycling is where a shorter vector is going to be looped through a larger vector. Let's just do a random case here. Let's say, I don't know, letter K is going to be equal to a list of, let's say, 5, 6, and 7. Let's create K real quick. Okay, so K is 5, 6, and 7. We want to add this to another vector here. So let's just say X plus K. We're going to add these together. And you'll see now that our x plus k is going to be 6 elements in length, not 3. The reason being here is that when we had x right here and we added it to k, which is 5, 6, and 7, we end up doing 5 plus 1, which is going to be 6. And then we do 6 plus 2, which is going to be 8. And then 7 plus 3, which is going to be 10. And then we start over again with the short list. So now the short list is going to be 5 plus 4, which is going to be 9, and then 6 plus 5, which is going to be 11, and then 7 plus 6, which is 13. And you can do the exact same for multiplication. Let's just put a small note here that, the ordering doesn't matter. So why I'm stating this is this case was like a 6-element vector plus a 3-element vector. So this is fine. You can actually do it the other way around where you would have a 3-element vector plus 6. It does the exact same. It doesn't really matter. I'll show you here just to prove to you quickly. We'll get the same results. And you can see here they both match. Okay, and finally to wrap this video up, there are other operators which you might need. These are going to be the modulus, the integer division, and the exponent. What we're going to end up doing is just looking at them quickly. So if you don't know what a modulus is going to be what we like to call in like basic math the remainder. So let's just take a simple example here. Let's do 5 modulus 2. So what this means is 5 divided by 2. 2 is going to go into 5 2 times. Okay, so 2 times 2 is 4. And then we're going to have a remainder of 1. So we should see 1 as the modulus here. Okay, 1 is going to be the modulus. This is important for a variety of reasons. You can use it for looking at like odds versus even numbers. There's just weird programming applications where it comes in handy. I'm not going to do an exact example here, but it is quite useful in some scenarios. So the other one is going to be integer division. So this is going to be basically the opposite of a modulus. So let's just look at the example we did below. So we had 5 integer division 2. What this is going to give us is, right, we should expect 2 here. The reason being is 2 goes into 5 how many times? It's 2 times plus some remainder up here, which is going to be 1. So if you run this, this will give us the whole integer number. So 2 goes into 5 how many times as only an integer, and it gives us 2. Let's just quickly do other examples. So another example, so you can kind of see how this works. Let's do 10 divided by 3. And this should give us 1 again, because 3 goes into 10 3 whole times, and you'll have 1 as the remainder. So this will be 1. Another example, this I guess we'll make it a little, let's just do 11. So we get something besides 3. This should give us 2, because 3 goes in to 11 3 times, which is 9. The remainder here is going to be 2, so 9, 10, 11. So let's run this just to show you. Okay, it gives you 2. And then on the flip side, right, so the opposites of these are going to be 10 integer division of 3. This should give us 3. And if we did 11 integer division by 3, this should also give us 3, because 3 goes into 11 3 times the remainder of 2. So let's just run these real quick. So 3 as we expected. And this also gives us 3. Okay. And then finally here, just the last one here is the exponent. So a lot of times we need to square values. So let's just take simple math here. Let's just do 4 squared, and this should give us 16. But let's look at this for vectors. So again, all these can be applied to vectors as well. Let's say x is going to be raised to the 3rd power here. Copy and run this below. And then again, remember x is 1, 2, 3, 4, 5, 6. 1 cubed is going to be 1. 2 cubed is 8. 3 cubed is 27, and then continues on. Anyways, that's kind of the basics of operators and vectors. Thanks for watching. Don't forget to like, share, and subscribe. And as always, until next time.